Hi everyone. In this class, I will explain what is meant by combination and how to use combination in solving some questions, particular questions. This concept is very simple. We do not require any higher knowledge. Combination means selection of objects. Combination means selection of objects. Suppose, for example, we went to a shop and we want to buy some t-shirts. Suppose there are some 4 shirts are there. They all have different colors and different sizes, of course. Now you want to select one shirt, right? So you can select one shirt, either red or green or yellow or white shirt. So there are 4 ways. Suppose you want to select 2 shirts out of 4 shirts, right? You can write the combinations. You can write the combinations. Combination means combining the things. So like red and white, red and green, red and yellow. These are the 3 cases. Means you choose one color first and assign another color. Okay. Next, take the second color and choose the remaining next 2 colors. Leave the first one like that. I will explain here. Well, here is a question. I'll explain the concept through the question. In how many ways one can select 2 shirts out of 4 distinct shirts? Right. So let us list out all possible cases. We have 4 shirts. We have 4 shirts. Name them like S1, S2, S3, S4. We want to select 2 shirts. We want to select 2 shirts. Right. What are the possible selections? Possible selections. Possible selections are, here is the procedure. Begin with S1. Begin with S1. Now S1, S2. S1 and S2. Or S1, S3. Or S1, S4. Okay, so combination with S1 is over. Now remove S1. Now you take S2. Begin with S2. S2, S3. Means we can select second shirt and third shirt. S2, S4. Combination with S2 is over. Now S1 is over, S2 is over. Now begin with S3. So the last one is S3, S4. Here we want to select 2 shirts out of 4 distinct shirts. We do not bother about the order of shirts. We should not think of in which order they appear. Just we want to select only 2 shirts out of 4 distinct shirts. There are 3 combinations with S1 and 3 combinations with S2 and 3 combinations with S3, of course. So there are 6 possible combinations. There are 6 possible combinations or 6 possible selections. 6 possible selections. That selection is also known as a combination. There are 6 possible combinations. Combining search with one search, S1, S2, S1, S3, S1, S4. If we have a 5, S1, S5. Okay, begin with S1, next begin with S2, next begin with S3, next begin with S4, next begin with, that's it, over. If we have 5 search. Now you see here, order of search is not considered. Order of search is not considered. Wait. Order of search is not considered. Okay. If the order of search is considered, then it becomes a permutation. So the major difference between permutation and combination is, in permutation, the order of objects is important, whereas in combination, the order of objects is immaterial. Right. So here we have a 6 possible cases. We have a 6 possible cases. 1, 2, 3, 4, 5, 6. So 6 into, okay, each pair can be arranged in 2 factorial ways. Each pair can be arranged in 2 factorial ways. That is nothing but, this is nothing but the number of permutations of 4 shirts taken 2 at a time. This is equal to the number of permutations of, or the number of arrangements of, two shirts, 4 shirts taken 2 at a time. All are different, of course. 4 shirts taken 2 at a time. Taken 2 at a time. Well, with each pair, we have a 2 arrangements, as there are 6 selections, 6 into 2 factorial. When we are doing an arrangement, it becomes a permutation. So, according to the formula, this is nothing but 4p2. This is a permutation. So, therefore, I can write that this is equal to 6 equal to 4p2 by 2 factorial. All right. So this is equal to 4p2 by 2 factorial. So this is the number of ways, of selecting, the number of ways of selecting 2 shirts out of 4 different shirts, from 4 different shirts. Right? I hope you understand. One is when the order is not considered, other one is when the order is considered. If order is considered, then it becomes a permutation. If order is not considered, then it becomes a selection, or you can say combination. So the number of ways of selecting 2 shirts out of 4 shirts is 6. That is equal to the number of permutations of 4 shirts taken 2 at a time divided by 2 factorial. So similarly, I can write that if I increase the number of shirts, the number of ways of selecting three objects. Okay, instead of search, I am taking three objects from five distinct objects. From five distinct objects. This is equal to, according to the above representation, here 4P2. Here we are selecting 3 out of 5. So you write 5P3 by 3 factorial. It becomes 5 factorial by 2 factorial into 3 factorial. We represent this notation by 5C3. We are selecting 3 objects. 5C3. Here C stands for combination. Now we can generalize. The number of ways of selecting R objects from n distinct objects is now NCR. NCR equal to n factorial by R factorial into n minus R factorial. I'll write that. The number of combinations is same as of the number of ways of selecting R objects from n distinct objects, right? Equal to, according to this formula, NPR by R factorial. NPR by R factorial. This further we write n factorial by NPR means n factorial by n minus R factorial by R factorial. This we represent NCR. C stands for combination. There is another representation. We write NCR like this. Or sometimes we write C of n comma R. So NCR means the number of ways of selecting R objects out of n distinct objects. For example, there are 5 persons. The number of ways of selecting 2 persons out of 5 persons is 5C2. For example, there are 13 cricket players. There are 13 cricket players who got selection for the Indian team, right? For a match, anyway, they have to take only 11 players. So the number of ways of selecting 11 players out of 13 players is 13, see 11. Suppose there are 9 digits, 1 to 9. The number of ways of selecting 4 digits is 9C4. I'll explain this concept and I will apply this concept to solve some kind of questions. First question. Here are a few examples based on the number of ways of selecting R objects from n dissimilar objects. What is the number of ways of selecting 3 boys out of 5 boys? The number of ways of selecting 3 boys out of 5 boys. Just instead of objects, we have taken particular things, that is boys. So is 5C3. That's equal to 5 factorial by 3 factorial into 2 factorial. 5 factorial is 5 into 4 into 3 into 2 into 1, 120 by this is 6 into 2. That's equal to 10. I will explain how to do in a simplest way. Now you see the number of ways of selecting how many balls? 4 balls. From 3 white and 4 black balls. There are 3 white balls. There are 4 black balls. We want to select 4 balls. Right. So out of 7 balls, you want to select 4 balls. There are 7 balls. So therefore, this is equal to 7C4. 7C. This is equal to, using the same method, this is also equivalent to 7C3. Using the same method, you will get 35. See the last question. The number of ways of selecting 3 batsmen and 3 bowlers from 6 batsmen and 5 bowlers is equal to is. Okay. So out of 6 batsmen, you have to select 3 batsmen. Okay. So is 63. And when there is an end, using multiplication rule, we have to multiply it. Right? You have to select 3 batsmen from 6 batsmen. That can be done in 63 ways. And end means multiply. You have to select 3 bowlers out of 5 bowlers into 63. You find that 63 is nothing but 6 factorial by 3 factorial into 3 factorial. Well, okay. So that is 20 into 10. This is equal to 200. So now, here R lies between 0 to n. Anyway, we can't select objects more than objects which we have. If we have 10 objects, we can't select 11 objects. Okay. So now, what is NC0? NC0 is 1. What is NC1? This is n factorial by 1 factorial into n minus 1 factorial. So n factorial means n into n minus 1 factorial by n minus 1 factorial. Cancel. This is equal to n. All right. What is NC2? NC2 equal to n factorial by 2 factorial into n minus 2 factorial. This is equal to n factorial by, or n into, I can write n minus 1. Next one is n minus 2. So instead of going after n minus 2, put factorial. By 2 factorial is nothing but 2 into n minus 2 factorial. Now cancel that n minus 2 factorial. We got directly n into n minus 1. These formulas will help us to simplify these combinations very fast. Well, so now you see NC2 is nothing but n into n minus 1, product of 2 numbers by 2 factorial. So now directly we can write NC3 n into decrease 1, again decrease 1. Only you have to write 3 products by 3 factorial. And NC4 equal to n into n minus 1 into n minus 2 into n minus 3 whole by 4 factorial. Like that. We don't need more than this, in fact. And also we have that NCR equal to NCS, NCN minus R. NC are equal to NC n minus R because both are equivalent to n factorial by R factorial into n minus R factorial. One is n, another one is R, and another one is difference of these two. Here n minus R, and difference of these two is again R. So therefore, sometimes instead of writing 5C3, directly you can write 5C2. 7C4, we can write 7C3. So 7C3 means 7 into 6 into 5 whole by 3 factorial. So 3 factorial, nothing but 6, cancel. So we can write directly, it is 35. So NCR equal to NC n minus R. Both are same. And also we have that NCR equal to NCS implies either R equal to S, either R equal to X, both are equal, or R plus S equal to M. Sum of these two. Either R equal to S or R plus S equal to M. Now, of course, we do not require these formulas for CSAT. We require for only JEE Main and JEE Advanced. There is another question based on this combinatorics. I'll write now. See, this is a little bit difficult. The number of 3-digit numbers whose digits are in increasing order. The number of 3-digit numbers whose digits are in increasing order is dash. This is the question. The number of 3-digit numbers whose digits are in increasing order. Well, solution is quite simple. Okay, for example, we have to find the 3-digit numbers wise 1, 2, 3. The digits are in increasing order. Or 1, 3, 4. Or 1, 3, 8. We want to find the number of 3-digit numbers whose digits are in increasing order. Anyway, in these numbers, 0 will not appear because the digits we have to arrange in the increasing order. So anyway, 0 will not come. Now, what to do? You see, select 3 digits. Select 3 digits. Select 3 digits from 1 to 9. From 1 to 9. Right? It can be done in 9C3 ways. It can be done in 9C3 ways. We want to select 3 digits out of 1 to 9. Right. Okay. Say A, B, C are the selected digits. A is less than, B is less than, C are the selected digits. Okay. Like 1, 2, 3. Like 1, 2, 3. Now ABC can be arranged. A, B, C can be arranged in increasing order. Can be arranged in increasing order. In increasing order. Only one way. only one way in increasing order. Okay, in one way. That is first A, next B, next C. Right. See, there are 9 C3 selections. There are 9 C3 selections. For each selection, you will get only one 3-digit number. For each selection, we get only one 3-digit number. For each selection, we get only one 3-digit number. If you select 1, 2, 3, you will get 123. If you select 7, 8, 9, you will get only one 3-digit number 7, 8, 9. Right? So as there are 9 C3 selections, for each selection you can form only one 3-digit number. Therefore, the number of 3-digit numbers is equal to 9C3. So therefore, required ways equal to 9C3. Once again, I am explaining for each selection. Whenever you select 3 digits from 1 to 9, okay, you can arrange them in increasing order only one way. If you select 1, 3, 5, the required number is only 135. For each selection, you can frame only one 3-digit number. So the number of required ways equal to 9C3, that is 9 into 7 by 3 factorial. Okay. So therefore, this is equal to 3 into 4 into 7. That's equal to 84. The number of shake hands among n persons is, assume that every person shake hands with each of remaining persons. Well, so here what is the number of shake hands among n persons? The answer is quite simple, that we have to select two candidates. We have to select two candidates or two persons out of n persons, so that they each may shake the hands. So answer is quite simple, that is n seat. Select two persons. Select two persons. So it is simply nothing but selection of two persons. It is simply nothing but selection of two persons. For example, I'll write P1, P2, P3. Okay. P1 can shake hands with P3, and P1 can shake hands with P2, and P2 and P3 also can shake hands. So we are just choosing two persons. P1, P2 shake hands, P1, P3 shake hands, and P2, P3 shake hands. So what are we doing here? We are just selecting two persons out of three persons. If there are four persons, the number of handshakes is the number of shake hands is only 4C. The number of shake hands is only 4C. I'll give an example of previous CSAT exam here. So if there are 5 persons, the number of handshakes or shake hands, whatever it may be, is equal to 5C. Here is a question of CSAT 2021. 2021. There are 6 persons arranged in a row. Well, another person means you can think of you or me or somebody else, has to shake hands with 3 of them so that, listen, he should not shake hands with two consecutive persons. He should not shake hands two consecutive persons. In how many ways, distinct possible combinations, can the handshakes take place? Very nice question, but very simple also. Here I list out the persons, okay? Here I list out the persons P1, P2, P3, P4, P5, P6. Yeah. Suppose you, okay, want to shake hands among these, you want to shake hands 3 persons among these 6 persons. But among those 3, no 2 of them are consecutive. No 2 of them are consecutive. With this should not shake hands with the 2 consecutive persons. So you can do like this. You can shake hands. You can shake hands with, okay, select 3 persons. Begin with P1. Begin with P1. Now you can't choose P2. So go for P3. Now you can't choose P4. Now go for P5. Listing out possible cases when a number is very small is very simple. Of course, there is a direct formula, but we should not require now. Now, P1, P3, you can choose a last person P6. These are the possible cases. Begin with P1. See, no 2 of them are consecutive. You are not shaking hands with the 2 consecutive persons. Now begin with P2. Begin with P2. You cannot choose P3. So you have to choose definitely P4. And now you cannot choose P5. Now you have to choose only P6. Well, now P2. Okay. Anyway, you can't choose P3. Okay. Now, if after P4, if you take P5, then who else the third one? You must choose P6. You must choose P6. But P5 and P6 are consecutive. So there is no other case. There is no other case with P2. With P2, it is not possible. There is only one case. All right. Now, begin with P3. Begin with P3. Anyway, you can't choose P4. You can't choose P4. So if you choose P5, and immediately there is one possible case, P6, this is not correct. This possible is not our requirement. Okay. This is not our required case. So there are only now P3 with P3 over. Anyway, with P4, it is not possible at all because you want to choose 3 persons. So listing out this is very simple question that there are only 3 cases. Like this. I'll bring one more question on shake hands. Everybody in the room shake hands with everybody else. The total number of shake hands is 66. The total number of persons in the room is dash. Now, instead of asking the number of shake hands, they are asking that how many persons are there in the room if the total number of shake hands is 66. Right. Suppose there are n persons. Suppose there are n persons in the room. Then the number of shake hands is number of shake hands or handshakes equal to, according to our formula, we get MC2. It is given equal to 66. So therefore, MC2 is nothing but n into n minus 1 by 2 equal to 66 implies n into n minus 1 equal to, you will get 66 into 2. Okay. See, this is a product of two consecutive integers. Product of two consecutive integers. 66 I can write 11 into 6 into 2, that is 12. So this is also product of two consecutive integers. If this is n, then this is n minus 1. Hence, there are 12 persons. In the next video, I will explain few more examples based on this, and I will explain a combinatorial geometry. Combinatorial geometry means if some points are given on the circle, how many right triangles can be formed, how many equilateral triangles can be formed, how many diagonals can be formed, and if a chessboard is given, how to select the squares lying on the main diagonal or any diagonal, etc. These all I will explain in the next video.